Hello, I am Luis Nuño. I am a professor in the area of signal theory and communications at the Polytechnic University of Valencia in Spain. And now I am going to explain you the intervals in music. An interval is the distance in pitch between two notes. This distance could be expressed as the number of half steps between them, but it is usual to express the interval with a number and a quality, and the quality is based on the major scale. There is a very important kind of intervals called consonant. A consonant interval is a combination of two notes that, when played together, produces a sensation of harmony, rest, and stability. They are composed by any two of the first harmonics of any given note, harmonics 1, 3, and 5. So, in order to study the intervals, for example, from note C, we need the C major scale, which is given, for example, by the musical abacus, and we need also the harmonics of C, which are given by the musical abacus too. In these harmonics, the most important ones are number 1, 3, and 5, that is notes C, G, and E. The intervals among these notes are always consonant. The reason is because we are used to hear these three harmonics simultaneously. Here we have a chromatic circle where we have marked the notes of the C major scale, C, D, E, F, G, A, B, and the harmonics of C. The most important ones, number 1, note C, number 3, note G, and number 5, note E. The interval from C to G is named with a number. If we count the natural notes from C to G, we have C, D, E, F, G, 5 notes, so this is a fifth interval. And because the note G is practically at the same place of harmonic 3, this interval is called perfect. So this is a perfect fifth, and it has 7 half steps. The inversion of the interval means to invert the order of the notes. So instead of going from C to G, we go from G to C. Now we have G, A, B, and C, 4 notes, and this is a perfect fourth. The perfect fourth has 5 half steps. When inverting an interval, there is a rule which says that the sum of the numbers is always 9. In our case, the starting interval was a fifth, and the inversion is a fourth, so 5 plus 4 makes 9. We can fold the perfect fourth interval starting with note C. In that case, we have to count 4 notes, 4 natural notes, C, D, E, F, and because this interval has 5 half steps, it is directly a perfect fourth. The musical abacus provides us all the major scales and the intervals from the tonic of every major scale to the other notes in its scale. For example, here we chose the C major scale, and we can see that from C to F we have a perfect fourth, from C to G we have perfect fifth, and from C to again C we have perfect first, which is called also unison, and from C to the next C we have a perfect eighth, which is called octave. The term octave comes from the Latin language. Now consider the other intervals from C to E. We have C, D, E, 3 natural notes, so this is a third interval. Now the note E is not at the same place as harmonic 5. It's near it, but not very near. So this interval is not perfect. It is called major. The major third has 4 half steps. The interval from E to G, the other two harmonics, has 3 notes, E, F, G, so it is a third, but it has 3 half steps, 1 less than the major third, so this is called a minor third interval. We can verify this by going to the E major scale, and here we have the intervals from the tonic, and from E to G sharp we have a major third. So from E to natural G we have minor third. We can observe that in any major scale the interval from the tonic to the fourth, fifth, and eighth are perfect, and the rest of the intervals are major. In this table we have the notes of the C major scale in the first column, then the name of the intervals from the tonic, and in the last column the number of half steps. With this table we can find any interval from note C. For example, from C to A flat we have a sixth interval, but it has a half step less than the major sixth, so it is a minor sixth. It is the same case as if we go from C sharp to A, we have a minor sixth. If we start with C sharp and we go to A flat, we have two less half steps than in a major sixth, so it is called diminished sixth. On the other hand, if we go from C to A sharp, we have one more half step than in a major sixth, and it is called an augmented sixth. In the case of perfect intervals, we don't distinguish between major and minor. So from C to G sharp, we have one more half step than in a perfect fifth, and we call that interval augmented fifth. From C to G flat, we have one less half step than in a perfect fifth, and we call it diminished fifth. From C sharp to G, we have also a diminished fifth. But what about if we want to know the intervals between any other two notes? We only have to delete the first column of this table. For example, now if we want to know the interval from G to B flat, we have G, A, B, three notes, but three half steps. So it is a third, which one half step less than the major third, so it is a minor third. For example, from F to D, we have F, G, A, B, C, D, six notes. It is a sixth, and the number of half steps is 9, so it is a major sixth. Now we consider the inversion of the major third interval. That is, we go from E to C. Number of notes are E, F, G, A, B, and C is a sixth, and the number of half steps in this interval is 8, one less than the major sixth, so it is a minor sixth. The sum of the numbers in two intervals, 3 plus 6, is 9. We can verify that the interval between E and C is a minor sixth, because if we go to the E major scale, we can see that from E to C sharp we have a major sixth. So from E to natural C we have minor sixth interval. Now we can invert the interval between E and G. That is, we go from G to E, the number of notes G, A, B, C, D, E. It is a sixth, and it has 9 half steps, so it is a major sixth. If we compare this case with the previous one, now we started with a minor third, which has 1 half step less than the major third. It means that when we invert the minor third interval, we will obtain 1 more half step than in the previous case. That's the reason why when we invert a major interval, we obtain a minor 1, and vice versa. When we invert a perfect interval, we obtain a perfect interval 2, and when we invert an augmented interval I, we obtain a diminished 1, and vice versa. Here we can verify that the interval from G to E is a major sixth. Now we can summarize the consonant intervals. They are the perfect fifth, the major third and minor third, as well as the inversions, the perfect fourth, the minor sixth, and major sixth. As conclusions, we can say that an interval is the distance in pitch between two notes, and they are named by a number and equality. The equality of the interval is based in a major scale. In any major scale, all the intervals from the tonic are major or perfect. When we invert an interval, we have two rules. The sum of numbers is 9, and the inversion of perfect is perfect, the inversion of major is minor, and vice versa, and the inversion of augmented is diminished, and vice versa. A consonant interval is the combination of two notes that, when played together, produces a sensation of harmony, rest, and stability. They are the perfect fifth, major third, minor third, and their inversions perfect fourth, minor sixth, and major sixth. You can find all the information on the webpage harmonicool.com. Thank you very much for your attention.